Hi everybody, my name is Xiaoyu Chen, and I'm an MH student of computer engineering. Here is a speed bump on King's College Circle. So we'll normally drive over it. Sorry. It feels very bumpy, but when you drive over it above certain speed, it seems like the bumpiness you feel is smaller. So have you ever wondered if there's any correlation between the bumpiness and the speed? So the goal of this app is to find out the answer. So this app utilizes the two sensors in our phone, which are the accelerometer and the GPS. And it has data process element as well as a database to process and store the data. And the data will be visualized by the plot drawing block and presented to the user. Okay, let's move on to the demo. You can create different profiles for different cars. Say I want to create a profile, say Lambo. Yep, then you press the new measurement button to start a measurement. There are two detection modes for the measurement. There are manual mode and auto mode. Right now I'm in manual mode. In manual mode, you need to start and stop. Let's start a measurement. Start and stop the measurement manually, and select where the bump is manually. And right now you can use the GPS ratings here, but you can also edit the speed and press save to save the data. Okay, let's move on to the auto mode. So there are several threshold values that need to be configured for the auto mode. The first one is the threshold for the acceleration difference, which will determine the start point of a bump. And also, the detection is only enabled when the location is near a bump. And you can easily add a location of a bump by pressing the Add Bump button. Then the current location will be added to the database. So add it. Yep. And also, the speed can be determined by the GPS readings. And if you also know the length of the bump plus the car, you can actually calculate the time the car will spend on the bump, so you can determine the end of a bump. So the first step is to register all the bumps under test. Here there are 7 bumps around the King's College Circle. I use 5 of them. And there's a switch to toggle between the manual and auto mode. These two are the threshold value settings. And this calibrate button could be used to calibrate the length of the bump and the car. What you need to do is just start a measurement. Let's say like start and endpoint, then you click calibrate. It will automatically calculate the length of the bump and the car. So it will be used for the auto detection mode. So I'll show you how it works. So right now the threshold value for the detection is 3.5. So I just maybe the GPS is not fully working indoors, so let's just try to just increase this distance threshold values. You can see it start automatically. And also, if you like change this threshold value, you need to like shake it really hard to start the measurement. So it basically sets the sensitivity for detection. So here's a video showing the measurement process. This part is no sound, but yeah, it actually started the measurement. So yeah, the data is saved to the database. Okay. The auto detection works very well as long as you keep the speed constant for a period of time before hitting the bump, because there are always some delays, and always has some delays for the GPS readings, and also the polling rate is not too good. It's fairly low. It's like 1 second, 1 per second. So, so the auto detection function doesn't work very well in high speed, saying like higher than 25 kilometer per hour. So for the testing, I didn't get quite good, like much data for the high speed. But as you can see, for the manual mode, on the plot on the left, I can see the trends that the bumpiness do fall after like 20 kilometer per hour and stays there. There's another thing you can notice, that the Mini Cooper actually have a better suspension system than the Fiat, because the value, the bumpiness value is smaller. Yeah, the future work will be like improve the algorithm for the auto detection, as well as make it less GPS dependent, and maybe add more features such as map annotation. Yep.
Hey, that's a lot of work. It's interesting to see the idea fleshed out. Just one question. There's something you call a bumpiness measure in some of those plots.
Yep.
That's different. The same bump will get different bumpiness for a different car, I think. Is that what you're explaining by those two measurements? So there's no way to make an absolute bumpiness measurement.
Yeah, it's too many variables.
It's
yeah.
always going to be a function of the car itself.
Mm-hmm.
Cool. Any other comments? Yeah.
How did this research proposal arise? I'm just wondering.
Oh, I can answer that.
Yeah.
One day I was riding around King's College Circle on my bicycle, and I hit those bumps, and it almost threw me off. Now that's not the end of the story. Then I was driving around King's College Circle in my car, and I did not notice the speed bumps. I was infuriated. Oh, sorry, that's not even it. Those speed bumps have, because they noticed that bicyclists are almost killed by them, they filled in the speed bumps in the middle of the road. So the bicyclist is now required to drive in the middle of the road in order to avoid being thrown off the bike, putting themselves at risk. And it's ridiculous. It would never pass ethics testing if it was an experiment here. So I've been infuriated about a year and a half, and so I wanted to see the measurement of this fact that the speed bump doesn't actually do anything. So I wanted to, so that's working for me. So I'm just questioning.
Yeah.
An infuriated question. Any other questions?